guys able to hear me okay? Awesome. First of all, I'm super excited to be here. This is my first time in Madison. So my name is Sudhi Bhat. I go by Sudhi Bhat. I'm a principal specialist solutions architect at AWS. My area of expertise is in compute. We are a team of, I would say, 80 globally. The team that I work in is responsible for helping some of our customers scale cost effectively in the cloud, specifically from a compute standpoint. So why am I here specifically talking about a commercial offering in front of a bunch of PhDs and academics background? Because we do have a lot of customers who are, the clicker seems to be not working. No worries. So we do have a lot of customers leveraging Condor in the cloud, specifically for research use cases, doing some type of simulations. And what we have noticed is by leveraging some of the best practices, they were able to achieve operating at scale in the cloud, right? So I'm here to potentially give you some of those best practices and the tools that could potentially help if you were to consider running some of your Condor workload in the cloud. And also, we'll go through some of those case studies that might show you some of the examples of how some of our existing customers have been running Condor in the cloud successfully to operate at scales of like 100,000 cores to a million cores in some cases, right? So predominantly, two main types of use cases that we see being leveraged by Condor and running in the cloud, right? As you might know, the compute-heavy use cases where like the simulation use cases or the risk modeling, especially in the financial services, those tend to be predominantly focused on latencies and large scale where they want to concurrently execute large number of tasks to predominantly come up with the hypothesis or a better simulation ratings, whatever use case may be, right? And the other bucket of use cases is around data. So as we discussed earlier, there was like drug sequencing, genomic sequencing, as well as some of the research use cases. They all tend to be concentrated around data and doing some type of ETL type of jobs or maybe any type of specific set of access patterns that they may be having. They tend to leverage Condor in the cloud as well, right? So in the last couple of years, especially, we've been noticing a lot more use cases being looked into running in the cloud, specifically for those workloads, either being used as an overflow mechanism or even natively deploy that thing in the cloud to run Condor effectively. So what is driving this transformation? So there are a variety of reasons. I would say one of the key important things is the ability to go time to market, ability to conduct these experiments quickly so that we can produce the results and move on to the next project, whatever you have, without really having to purchase this large number of compute in your colo facility, right? And the other things that we also see is there's a lot of skill shortage, and as well as the cost, especially if you're trying to run like a million core experiments, cost can be pretty significant, especially if you're trying to build those infrastructure in-house, right? So how do we see architecturally Condor being used in AWS? So predominantly, there are two main ways we see architecturally Condor being deployed and leveraged. This is a grossly simplified architecture, but the key point I wanted to highlight here is that there are three main aspects, especially when you're trying to acquire this large scale capacity in the cloud. There are three main components that you need to understand, especially if you want to make sure that you're scaling cost effectively, as well as scaling by focusing on the performance aspects as well. The number one would be the compute, the second one would be storage, and finally the networking, right? So if you want to optimize, those are the three areas where you would start first. And as you can see here, typically when you deploy a Condor, you would have a bunch of compute nodes running as an executor node here, as well as you have the submitter node and the central manager node. The executor nodes are the ones tend to be the compute heavy. which directly attributes to the cost that is associated with that as well, right? So in this architecture, you can see that the Condor is deployed natively in the cloud, and the popular architecture that we tend to see more often, where especially customers who are trying to run these overflow use cases in the cloud, in conjunction with their on-prem, they tend to use this particular architecture, right? So they either use Condor Annex. Those of you who are not familiar with it, it allows you to extend your compute pools to the cloud or any other facilities that you may have. And the key thing to note here is, again, the executor nodes are the one that tend to drive more of the compute and in turn the cost, right? So the best way to get started with the optimization, especially when you're trying to operate at a large scale in AWS, would be to leverage the purchasing options, the different cost aspects that are associated with your compute. And the other advantage is by leveraging the right set of compute instances for running your workload, you can be more cost effective as well as focus on your performance, right? And AWS does allow you to leverage a bunch of tools that we have, which consistently help you optimize and right size your resources as and when you need, so that you're more efficient. So the picture here that kind of depicts that by applying some of those best practices and leveraging some of those features that we have, which we're going to discuss now, you will be able to attain a better cost to price value while running these workloads in the cloud, right? So starting with the purchasing options and the compute options, as you might know, AWS already offers over 750 different EC2 instances. EC2, for those of you who are new, it's the Elastic Cloud Compute, right? Similar to the virtual servers that you may have. So there are a variety of compute choices that you might choose from, which are either memory or compute optimized, or if you have a graphics use cases that are, we have dedicated EC2 offerings around those use cases. And we also have HPC-based use cases, which are high clock, which come with high clock speed, better network bandwidth for performing whatever the compute-intensive tasks that you may have. And finally, the GPUs and the other accelerated instances, those are purpose-built, which help you with doing any type of a computation that might require your GPU capacity or any other accelerated capacity that you need, right? I talked about purchasing options. What does that mean? So most of the customers, when they start their journey, on-demand instances are the best place to get started, right? You learn your use case, learn more about how it operates in the cloud. And once you have established that baseline, that's when you can actually start thinking into commitments to gain some type of cost savings, right? By switching to savings plan or reserved instances, you can get up to about 60% discount. And finally, the most common purchasing options that we see, especially with Condor workloads, is the spot instances, and which we're going to dive a little bit deeper into. And Condor Annex also supports the spot fleets. So spot instances, as you may or may not know, are the spare EC2 capacity that we have in AWS, which we offer to our customers at a steep discount, up to 90% discount compared to the on-demand pricing. And previously, before 2018, there used to be a concept of bidding for purchasing this, acquiring this spot capacity. And we completely got rid of that bidding concept, and now the cost is predominantly determined based on the long-term supply and demand, right? The only caveat while using spot instances is that it is an interruptible service. That means every time there is a need for those capacity, we give you a 2 minutes warning and we take that instance back from you. And that is the reason one of the best practices is to leverage the diverse set of EC2 capacity pools that we have behind the that we have in AWS to make sure that you are maintaining that high level of availability for running your workload, right? So with the interest of time, I'm going to quickly move on. So I mentioned interruptions are always going to be sent before the instance is getting terminated for spot instances at a 2-minute warning. That was not good enough for some of our customers, so they needed more time. So we recently introduced a new feature called rebalance recommendation signal, which could come potentially anywhere between like 2 minutes to 15 minutes, right? On an average, we see 70% of the time it comes about 10 minutes in time. The advantage of this is if you want to do some if you want to save some of the state of the task that you're doing, you could potentially leverage this. And how do you go about automating that? You can either we send this signal as a part of the metadata service, or you could also use some of our CloudWatch signals that you get, and you can build a Lambda and automate that. We have a ton of code samples that are already out there that you can leverage. I talked about being diversifying your instance selection is extremely crucial. And the reason for that is because for every instance family that we offer in a given instance size, belonging to a specific availability zone in a given region forms a separate capacity pool. So what does that mean? That means, like, let's say if you're using a C5 XL instance family in availability zone 1, for a XL size, it forms a dedicated capacity pool, right? So the advantage here is that by diversifying, you can actually see that you're going to massively improve the opportunity for you to acquire those capacity, especially if you're running like 100,000 cores or 1,000,000 cores. You want to have those capacity come from all over the EC2 options that you have, so that you can necessarily complete your job and move on, right? So this is the example that shows you that, like, let's say if you were using C6i large today, and if you introduce multi-AZ, you're basically increasing the pool from 1 to 3. And let's say if you introduce all of the C6 family to your configuration, the capacity pool choices drastically improves to 145, right? Then if you were to, let's say, introduce variants of M6i or R6i, as well as the AMD instances to your mix, your number of choices of capacity pool increases to 373. So the point is, if you want to operate at scale, being flexible in terms of your instance selection is extremely important, right? Quickly moving on. So when you provide these large number of EC2 selections, how does the APIs know which instance to pick from? So there are multiple choices available, especially for spot instances, right? So lowest price, as the name suggests, that will always give you the instance with the cheapest price. Not necessarily the recommended one, because it doesn't really consider the depth of the pool, right? So over the years, we have evolved and we have introduced capacity optimized and price capacity optimized. And when you are leveraging capacity optimized, the APIs are smart enough to get you those instances from the deepest capacity pool. What does that mean? It means the chances of you getting interrupted becomes significantly low, right? So the price capacity optimized combines best of both worlds, right? It also considers the cost as well as the depth of the pool while launching those capacities. So that makes it much more efficient for you to provision those instances. One of the other tools that we released recently is the spot placement score. So before even you start provisioning those instances, you can basically identify what is the optimal configuration for your running your use case. And by specifying your number of requirement as well as the vCPU and memory requirements, you can see the chances of you acquiring that capacity in a given availability zone or even a given region. Any score between, it's going to be a score between 1 to 9, any score above 5, the chances of you acquiring capacity significantly higher, right? So that's a tool, especially if you're trying to do a large model, like large simulation run or large experiment with lots of CPUs in place, definitely recommend you to check that out, right? And as a developer, it was much harder before to test your application for interruptions. So we made it possible to interrupt your instances using our fault injection simulator tool. This can be a very handy tool, especially when you're building your design as well as you're developing your application, right? The bottom line here is combining all of these purchase options effectively, especially some of our large mature customers, they combine all of these purchasing options effectively to optimize their entire compute cost, right? There are two other quick topics. I know we are kind of getting close to the time here that I want to touch upon is how do you build elasticity? So picking these 400 instances out of 750 instances, or even 35 instances out of the 700 instances can be complex, right? So our APIs do allow you to build your configurations based on your application. So rather than specifying the instance name, you can basically specify the minimum number of vCPUs and memory that your application requires, and those APIs will in turn go and pick the right instance for you, right? So we also made it available, this tool, as an open source project. So you can certainly use this to do fine-tune your instance selection as a part of your Condor configuration. The other neat thing that you could also do from a performance point of view is to leverage the ARM architecture-based instances, right? So if you're familiar with Condor class add mechanism, similar to the Kubernetes taints and tolerations concept, you could basically fine-tune your job execution on a specific hardware as needed, right? And Condor, if you're running containers, the ARM-based containers is also available. I think it was released like last couple of days, right? So why ARM architecture, especially the AWS Graviton is the ARM EC2 based instance. We see a lot of customers see advantages predominantly from a cost perspective. They are up to 20% cheaper, but more importantly, from a sustainability point, they are much more power efficient, right? So if you have a sustainability goal, definitely Graviton could be a better choice there. One other thing to note is we've done a lot of architectural improvements with Graviton, but the fundamental improvement comes from every vCPU in the ARM architecture in the Graviton world is a physical core compared to the x86 variants, right? Where every 2 vCPUs forms a physical core. So the performance improvements that are seen is purely attributed to that, but also there is no simultaneous multi-threading concept. That means that especially when you stress your cores beyond, like, let's say 60% of the CPU usage, the performance tends to be much better because there is no shared context that the cores have to, the tasks have to do and under the hood. So it is definitely much more performant oriented, right? And introducing Graviton or any other being flexible is straightforward as well. So if you are using launch templates today, one quick note on launch templates, if you're using launch configurations, definitely move away from launch configurations to launch templates because launch configurations are getting deprecated. So launch template allows you to leverage and be flexible much more easily. Like I showed here, you could quickly add multiple different instances as a part of your configuration and let the API take care of provisioning the right one, right? Along with the allocation strategy that we discussed. I know that I just have like a minute or two left. One of the common questions that we get these days, especially, is that AI, there's a lot of need for accelerated computing, right? Especially the GPU-based instances. So one of the recent services that we introduced was a capacity blocks, which allows you to basically block certain GPUs for a given period of time between 1 to 14 days. And this also offers a steep discount because you're reserving these instances advanced, right? So that's something that can be extremely useful, especially if you're trying to run some of these GPU-based use cases, right? I know I'm rushing it through here, so I will be here during the break, so feel free to ask me any questions then. But one last topic before we go to the case studies is there are multiple different tools that are available, like X-Ray, which gives you a visualization of end-to-end requests that you're processing, or the compute optimizers, which help you with some recommendations on right-sizing your EC2 instances that you can leverage to further continuously optimize your compute infrastructure that you're running in the cloud, right? One other note is all of these tools and techniques that we discussed are also available in the Gov Cloud. We see a lot of customers, especially in the public sector, use Gov Cloud because of the regulatory requirements that they have run in the Gov Cloud. So I just noticed that my time is up, but I have the material is available. Just to sum it up here, we do have multiple case studies. I've picked few in the content that I've shared. Take a look at it. I've also provided the links, but we do have some success stories that we published in our website that you can definitely take a look at it, where you can see how Condor is being leveraged in the cloud to deploy specific set of like a high HPC type of use cases, right? Again, I'm not going to go over in the interest of time, and I will pause here. That's like the end of my session. If you have any questions, I would be open to answer them.